Yeah, good evening, children. Good evening, Srijit and Sahasra.
Good evening, ma'am.
Okay, so in today's class, we are going to see some properties of rational numbers. Don't write anything. All the notes have been shared with you on WhatsApp. Okay. So first we'll see the closure property. So we'll see the closure property of addition of rational numbers, subtraction of rational numbers, multiplication of rational numbers, and division of rational numbers. That is, we'll understand if rational numbers are closed under addition, subtraction, multiplication, and division. Okay. Now, when you consider two rational numbers A and B, when you consider two rational numbers A and B, A plus B is always rational. A plus B is always rational. For any two rational numbers A and B, A plus B is always rational. That is, when you find the sum of two rational numbers, the answer is always rational. Similarly, for any two rational numbers A and B, if you find their difference, okay, the difference of any two rational numbers is always rational. So A minus B is always rational. Again, for any two rational numbers A and B, A into B, the product of A and B, is always rational. Again, for any two rational numbers A and B, their quotient is also rational, except when the denominator is 0. Except when the denominator is 0. So A divided by B is always rational, except when B is equal to 0. Therefore, we say that A divided by B is not rational. So in general, if you're asked this question, for any two rational numbers A and B, will A divided by B be rational? The answer is no, just for this exception. Because when B is 0, when the denominator is 0, like say 5 divided by 0, this division is not defined. The division is not defined. So A divided by B, for two rational numbers A and B, A divided by B will not be a rational number. That's only in this case where B is 0. In all other cases, it will be rational. In all other cases, it will be rational. But since there is one exception, we say that A divided by B is not always rational or is not rational. Now, I have to repeat this. Correct. Mixed fractions are also rational numbers. If you take this mixed fraction 1, 3 by 7, okay, so 7 into 1, 7, plus 3, 10, 10 by 7, integer by integer, rational number. Yeah, correct. So what are we talking about? We're trying to understand the closure property of rational numbers. Consider two rational numbers A and B. Okay, A is a rational number, B is a rational number. Find A plus B. What should you find? Find A plus B. You will see that the sum is also rational, always. Again, for the same two rational numbers, find A minus B. You will see that the answer, that is the difference, is rational, always rational. Again, for the two rational numbers A and B, find A multiplied by B. You will see that the product A into B, the product, is always rational. Similarly, for any two rational numbers A and B, find A divided by B. This result is always rational except when the denominator B is 0. Okay, when the numerator can be 0, because if it is 0 by 5, it is 0. 0 by 5 is 0. The numerator can be 0. The denominator, if the denominator is 0, the division is not defined. So remember, A divided by B is always rational, except when the denominator B is 0. When B is 0, A divided by B is not rational. A is rational, B is rational. And if B is 0, then A divided by B is not rational, because A divided by B, A divided by 0 is not defined. Only in this case, A divided by B, that is when B is 0, the division is not defined. So A divided by B is not rational. In all other cases, A divided by B is rational. So we say that rational numbers are closed under addition, subtraction, multiplication, but not under division. Because division, we have one exception. When we say it is true, it should always be true. Even if there is one exception, it is false. So rational numbers are closed under addition, subtraction, multiplication, and division. I repeat, rational numbers are closed under addition, subtraction, multiplication, and division. Closed under, meaning the closure property of rational number, the closure property of rational numbers holds true or holds good for addition, subtraction, multiplication, but not for division. Let me write that for you. These are the different ways of expressing. Okay. The closure property of rational numbers holds good or holds true. Holds good or holds true. Okay. Holds good or holds true for addition, subtraction, multiplication, and multiplication. Okay. Rational numbers are not always closed under division. Rational numbers are not always closed under division. Okay. So for two rational numbers, A and B, A plus B is always rational, A minus B is always rational, A into B is always rational. This means that rational numbers are always closed under addition, subtraction, and multiplication. A divided by B is always rational except when B is 0, because division by 0 is not defined. So because there is that exception, we say that rational numbers are not closed under division. Rational numbers are not closed under division, or the closure property does not hold good for division. The closure property does not hold good for division, or the closure property does not hold true for division, but it holds true or it holds good for addition, subtraction, and multiplication. All right, this is about the closure property. Yeah, Supposing the statement is rational numbers are closed under division except when, okay, for two rational numbers A and B, A divided by B is always closed except when B is 0. True. But if without that condition, if you're asked, rational numbers are always closed under division, false. If the statement is rational, say true or false. Rational numbers are always closed under division, false. Rational numbers are always closed under division, except when the denominator is 0. Except when the denominator is 0. Otherwise, rational numbers are closed under division, true. Otherwise, it's false. So next is the commutative property. Commutative property. Commutative, yeah, correct. Commutative property or commutativity. Commutativity. Commutative property or commutativity. Okay. So if A and B are two rational numbers, if A and B are two rational numbers, A plus B is equal to B plus A, and A into B is equal to B into A. But A minus B is not equal to B minus A. A divided by B is not equal to B divided by A. Okay, so let's take a very simple example. So let's say 7 plus 3 is equal to 3 plus 7. 7 into 3 is equal to 3 into 7. 7 minus 3 is not equal to 3 minus 7. 7 divided by 3 is not equal to 3 divided by 7. Correct. Because here 7 minus 3, the answer is 4. 3 minus 7, the answer is minus 4. This is 7 by 3. What is 7 by 3 as a mixed fraction? 2, 1 by 3. Navneet, 2, 1 by 3. And what is this 3 by 7? It's a proper fraction. Its value is less than 1. The value of a proper fraction is less than 1. 3 by 7, the value is less than 1. This one is 2, 1 by 3. Its value is more than 1. So they're not equal. So commutative property or commutativity, if A and B are two rational numbers, A plus B is equal to B plus A. That means the commutative property holds good for addition. And A into B is equal to B into A. That means the commutative property holds good for multiplication of rational numbers. Commutative property holds good for addition of rational numbers and multiplication of rational numbers. But the commutative property does not hold good for subtraction and division of rational numbers. That's what I've sent the notes for this. All right, children? All right? Okay. Associative property or associativity or associativity. Okay. So if A, B, C are three rational numbers, then A plus B plus C is equal to A plus B plus C is equal to A plus C plus B. That is, you can group the rational numbers in any order. You can perform this addition by grouping the rational numbers in any order. See, here you've grouped A and B. That is, you find A plus B, and then to that result you add C. Here you find B plus C, and to that result you add A. Here you find A plus C, and to the result you add B. See, whether you find A plus B first, B plus C, or A plus C, in all the three cases, the total sum, the final answer is going to be the same. So when you have three rational numbers A, B, C, you can group the rational numbers in any order and find their sum. The answer will be the same in all the three cases. Here you're grouping A and B, here B and C, here A and C. So the answer is the same, or the answer will be the same in all the three cases. So we say that rational number, we say that the associativity or the associative property holds good for addition and multiplication of rational numbers. The associative property holds good or holds true. The associative property holds good or holds true for addition and multiplication of rational numbers. Multiplication, because now this is also true. Correct? So you multiply the numbers in any order, the product is going to be the same in all the three cases. But this is not true. A minus B minus C will not be the same as A minus B minus C will not be the same as A minus B minus C. Sorry, A plus A minus C. Similarly, A divided by B divided by C will not be the same as A divided by B divided by C will not be the same as A divided by C divided by B. So the associative property does not hold good for subtraction and division of rational numbers. The associative property does not hold good or does not hold true for subtraction and division of rational numbers. See, associative property is about three numbers and adding them, multiplying them in different orders, or subtracting them, dividing them in different orders. And it's true for addition and multiplication, not true for subtraction and division. Associativity is about three numbers. Commutativity is about two numbers. You perform all the operations, addition, subtraction, multiplication, division, perform all the operations, but with two numbers. And here also it's true for addition and multiplication, but not for subtraction and division. The closure property is completely different. The closure property, I'll just repeat that. The closure property is when you have two rational numbers. Okay, so you consider two rational numbers. You add them. The result will also be rational. Take two rational numbers and find their sum. The result will also be a different rational number. Or if you're adding 0, it will be the same rational. See, like 5 by 3 is one rational number, 0 is another rational number. So 5 by 3 plus 0 is 5 by 3. So you can get the same rational number 5 by 3 if you're adding 0. Otherwise, it will be a different rational number, but it will be a rational number. Rational number plus rational number is equal to rational number. That's the closure property of addition of rational numbers. Rational number minus rational number is equal to rational number. Rational number minus rational number is equal to rational number. What other answer can you get? You're taking two rational numbers and finding the difference. The answer will be some different rational number. Similarly, rational number multiplied by a rational number is a rational number. A rational number divided by a rational number is always a rational number, except when that second rational number is 0. That second rational number, we say rational number divided by that second rational number, no? If that is 0, then it becomes division by 0, which is not defined. Except that case, in all other cases, rational number divided by rational number is also a rational number. But since we have that exception, we say that rational numbers are not closed under division, but they are closed under addition, subtraction, and multiplication, but not under division. If you take away that exception, they are closed under division also. So you can remember like this: rational number plus rational number is equal to rational number minus rational number is equal to rational number multiplied by rational number is equal to rational number divided by rational number is equal to rational number, except when this is 0. If that second number is 0, then it is division by 0, which is not defined. So because we have that exception, we say rational numbers are not closed under division, or the closure property does not hold true. The closure property does not hold good for division of rational numbers, but it holds good for addition, subtraction, and multiplication of rational numbers. So this is the closure property. Commutativity or commutative property. Associativity or associative property is with 3 numbers. This is with 2 numbers. Okay. Distributive property or distributivity. Both are the same. Distributive property or distributivity. Okay. Yeah. So for this also, 3 numbers. Okay, let's consider. So the distributive property, we have 2 types now. Distributive property of multiplication over addition and distributive property of multiplication over subtraction. These are the 2 things. Distributive property of multiplication over addition. Distributive property of multiplication over subtraction. Distributive property of multiplication over addition, distributive property of multiplication over subtraction. So for both, you need to consider 3 numbers, 3 rational numbers A, B, C. Okay, 3 rational numbers A, B, and C. Now the distributive property of multiplication over addition states that A into B plus C is equal to A into B plus A into C. And the distributive property of multiplication over subtraction states that A into B minus C is equal to A into B minus A into C. Okay. So this is true. So this is the distributive property of multiplication over addition and over subtraction. Okay. So now it's about the role of 0, the role of 1. Okay. Now we'll be seeing the role of 0, role of 1, additive inverse, multiplicative inverse. Multiplicative inverse is also called reciprocal. This is also called the negative of the rational number. It's not a standard term, but we can understand when you say that. See, the opposite operation of addition is subtraction. The opposite operation of subtraction is addition. So we do use the word opposite, but it's not a standard way of saying in this context. In this context, when you say opposite, it's not widely used. What is widely used is additive inverse or negative of a rational. Oh, it's not wrong. See, while teaching in the classroom, you can just say, see, when I'm addressing my classroom, I can just use that very informally. But it's not a formal way of saying I'm saying. Just to make children understand, we can just say, what's the opposite of, just put the opposite sign. Okay, so what's the negative of minus sign? Put the opposite sign, plus 5. So it's not strictly wrong, but these are the two terms used. Okay, so we'll see the role of 0, role of 1. These are different things. These are different things. Role of 0, role of 1. Additive inverse or negative of a rational number. Multiplicative inverse or reciprocal of a rational number. I'll just write the same things. Okay, let me just write it here. Okay, so we're going to discuss all these now. The role of 0, the role of 1. These actually it's the same. Additive role of 0 and additive identity. Both are the same. Role of 1. Different textbooks use different languages. So role of 0 and additive identity is the same. Role of 1 and multiplicative identity is the same. Okay. Additive inverse, multiplicative inverse. 1 minute. Let me just write the same thing in a more organized way. Sorry. Yeah. Okay. So what's the role of 0? Okay. Now, when consider a rational number A. Okay, A plus 0. What's the answer? A. And it's the same as 0 plus A also, right? Okay. So what happens when you add 0 to a rational number or a rational number is added to 0? In both the cases, the answer is the rational number itself. Okay. When we add 0 to a rational number or when a rational number is added to 0, when you add 0 to a rational number or when a rational number is added to 0, they're different. When we add 0 to a rational number or when a rational number is added to 0, you should see there. In both the cases, what is the answer we get? The rational number itself. The rational number itself. Navneet, you didn't watch me write that. All right. So when 0 is added to a rational number or when you add a rational number to 0, in both the cases, the sum or the answer is the rational number itself. So what do you mean by identical? Same answer, no? Identical. That's what is identity. Identity means identical answer. Same answer I'm getting. Won't you say that? A plus 0, I'm getting the same answer A. Or 0 plus A, I'm getting the same answer A. You're getting the same answer, meaning identical. It's identical. No, these two are identical. This rational number and the answer, they're identical, right? That's why identity. Now, additive identity because you're adding. So 0 is called the additive identity of rational numbers. 0 is called the additive identity of rational numbers because when you add 0 to a rational number or when a rational number is added to 0, the answer or the result is the rational number itself. So 0 is called the additive identity. When do you use this word identity? When you're getting the same answer. When will you get the same answer? On adding, when will you get the same answer as a rational number? When you add 0. When you add 0 to a rational number, you get the rational number itself as the answer, right? Yeah, that's why we say additive identity. Okay. So in some books, it's called the role of 0. Just wait. In some books, it's called the role of 0. Okay. But in general, it's, you should know this term also, additive identity. Additive identity. Now, multiplicative identity, or in some books, it's written as the role of 1. Okay. When a rational number is multiplied by 1, or you multiply 1 to a rational number, the answer is the rational number itself. The result or the product is the rational number itself. So if A is any rational number, you multiply that by 1, or to 1, you multiply some rational number. In both the cases, you get the same rational number as a result. And what's the operation used? Multiplication. And so when you multiply, when do you get the same answer? When you multiply by 1. By 1. That's why 1 is called the multiplicative identity. All the 4 are different. All the 4 you see on the screen, they're different. No, you will not get. There is no identity. There is no. What is the identity for subtraction? Tell me. That's why we don't have. You know, 9 minus 0 is 9, but 0 minus 9 is minus 9. 9 minus 0 is 9. You should get the same answer when you perform 0 minus 9. That's minus 9. Sorry? Successor of the number? Huh. What you're trying to talk about what? You repeat the whole thing? Successor of minus 1 is 0. Okay. Okay, 0 minus 1 is minus 1. Then 1 minus 0 is it? Is 1. Leave it. No, I'll ask you again. I don't know what you said. Okay, so a rational number multiplied by 1 or 1 multiplied by a rational number gives the rational number itself as a result. So we say that 1 is the multiplicative identity of rational numbers. Identity means you're getting the same answer as that of the rational number you've used. Getting the same answer. Whatever rational number you've used, you're getting the same thing as the answer. When will you get the same answer on adding when you add 0? When will you get the same answer when you multiply by 1? So multiplicative identity is 1. Additive identity is 0. Zero is the additive identity of rational numbers, and 1 is the multiplicative identity of rational numbers. What is identity? Identical means what? Same answer. same as that of the rational number which you have used. So on adding, when will you get the same rational number as answer? When you add 0. So the rational number says 5 by 7. You add 0 to this. What will you get? 5 by 7 itself. Same answer, identical answer. And you're doing what operation? Addition. So additive identity is 0. So in general, we write a plus 0. A plus 0 is equal to a, which is also 0 plus a. For a plus 0, the answer is a. Look at the board. 0 plus a, also the answer is a. Again, now on multiplying, when will you get the same rational number as the answer? When you multiply by 1. Yeah, so supposing you have a rational number like 10 by 13, you multiply 1. The answer is 10 by 13 itself, the rational number itself. Identical answer, same answer. So on multiplying, when will you get the same rational number as the answer? When you multiply by 1. So multiplicative identity, because same answer. So the multiplicative identity of rational numbers, the multiplicative identity of rational numbers is 1. Okay. So here we say a into 1 is equal to a, which is equal to 1 into a. That is a into 1 is a. 1 into a is also a. A into 1 is a. 1 into a is also a. And it's written as a into 1 is equal to a is equal to 1 into a. Now, sometimes in some books, you will find they'll take the rational number as a by b. Here we are taking a as a rational number. Sometimes they'll take a by b. Let a by b be the rational number. So a by b plus 0 is equal to a by b is equal to 0 plus a by b. So don't get confused. It's not two different numbers. A by b is a rational number. Integer by integer form, no? Integer by integer. So a by b is a rational number. Similarly, the rational number can be taken as x by y. X by y plus 0 is equal to is equal to x by y is equal to 0 plus x by y. Or they might just take, like we took simply a as a rational number. A as a rational number. So you can take the rational number as a, x, y, z, or like a fraction p by q, x by y. All right. Okay. Now next is additive inverse, which is also called the negative of a rational number. Additive inverse, which is also called the negative of a rational number. Okay. Additive inverse or negative of a rational number. That means when the sum of two numbers is 0, when the sum of two rational numbers is 0, then the first rational number is said to be the negative of the second rational number, and the second rational number is said to be the negative of the first rational number. When the sum of two rational numbers is 0, when the sum of two rational numbers is 0, then the first rational number is the negative of the second rational number, and the second rational number is a negative of the first rational number. So if you consider this rational number minus 7 and what will give you 0 as a result? Minus 7 plus what will give you 0 as a result? 7. There is no other answer. 3 and what will give you 0 as answer? Minus 4 by 11 and what will give you 0 as answer? 7 by 9 and what will give you 0 as a result? No. Negative means, as Navneet was saying, opposite. So you should not say positive. Okay. Yeah. So in these examples, you see that the sum of two rational numbers is 0. In all these examples, you see that the sum of two rational numbers is 0. Then the first rational number is said to be the negative of the second, and the second rational number is said to be the negative of the first. Let's read it. The negative of minus 4 by 11 is 4 by 11, and the negative of 4 by 11 is minus 4 by 11. The negative of minus 7 is 7, and the negative of 7 is minus 7. The negative of 3 is minus 3. The negative of minus 3 is 3. Or you can also say additive inverse. The additive inverse of 7 by 9 is minus 7 by 9. The additive inverse of minus 7 by 9 is 7 by 9. Okay. So when the sum of two rational numbers is 0, then the first rational number is called the negative or the additive inverse of the second, and the second is called the negative or the additive inverse of the first. So basically here what you do, you write the same number with the opposite sign. Write the same number with the opposite sign. So if you're asked to write the negative of minus 5 by 3, what is the negative of minus 5 by 3? Plus 5 by 3. What's the negative of 6 by 13? Minus 6 by 13. What's the negative of 0? Yeah. 0 is neither positive or negative. So the negative of 0, if you're asked the question, is 0 itself. For 0, it's 0 itself. Don't write minus 0 because 0 does not carry any sign. 0 is neither positive nor negative. 0 plus 0 is equal to 0. So that's about additive inverse or negative of a rational number. And finally, multiplicative inverse or reciprocal of a rational number. Multiplicative inverse or reciprocal of a rational number. So if the product of two rational numbers is 1, if the product of two rational numbers is 1, then the first rational number is said to be the reciprocal of the second, and the second rational number is said to be the reciprocal of the first. So when will you, let's consider 11 by 15 into what will give the product as 1? Into 15 by 11, 15 by 11. So 11 by 15 into 15 by 11 is equal to 1, correct? Okay. Minus 7 by 12 into what will give the product as 1? Sahasran, Srijit?
Ma'am? Yes, ma'am.
Yeah. No. I just want to check. You're following, right, all of you? Both of you?
Yes, ma'am. Yes, ma'am.
Okay. So minus 7 by 12 multiplied by what will give the result as 1? Minus 12 by 7. Because minus into minus plus 7 and 7 cancels, 12 cancels, minus into minus plus 1. Yeah, you can cancel, yes. Right? Now the product of 5 and what is 1? Srijit, 5 into what is 1? Sahasra, 5 into what is 1?
5. 1 by 5.
1 by 5. 1 by 5. 5 into 1 by 5 is 1 because 5 and 5 gets cancelled. It's 1. Not minus 1 by 5 because then it will be minus 1. That will be minus 1. For identity, see, there are two things. Okay. One is, okay, let's just finish this. So minus 7 into what will give you 1? Minus 1 by 7.
Minus 1 by 7.
Correct. 7 and 7 cancels. Minus into minus plus 1. So when you're writing the negative of a rational number, you must write that number as it is, but write the opposite sign. When you're writing the reciprocal of a rational number, invert the number, put the same sign. See, there are two changes which you can do. There are two changes which you can do. Inverting the number, writing the number upside down is one change. And writing the opposite sign is the other change. You can do two changes to a number. You can write the number upside down. That is one change. The other way of changing the number is writing the opposite sign. Okay. So, supposing the number is 7 by 9. You write this number as it is 7 by 9. You don't write it upside down. You write the same number. But instead of plus, you're writing minus. Then this answer is the negative of the rational number 7 by 9. This is the answer for the negative of the rational number 7 by 9. For the same number 7 by 9, if you don't change the sign, but you invert it, you write it as 9 by 7, then this is the answer for reciprocal of the rational number 7 by 9. If you don't disturb the number, but you disturb the sign, you can disturb the number or disturb the sign. But you should do only one at a time. You should not do both and ask what is that. You either disturb the number or you disturb the sign. If you disturb the sign, you're writing the additive inverse or negative of a rational number. If you disturb the number and not the sign, then you're writing the reciprocal or the multiplicative inverse of the rational number. So now but we have decided to disturb somebody. We will not keep quiet. We'll disturb somebody. Okay. Okay. So for additive inverse, disturb the sign. For multiplicative inverse, disturb the number. Now additive inverse. What's additive inverse of minus 5 by 7? Disturb the sign. Here, disturb the sign. Here, you disturb the number. Plus 5 by 7. Yeah, 5 by 7. Yes. Yeah. 9 by 17.
Minus 9 by 17.
3.
Minus 3.
Minus 25.
25.
Plus 25 or 25. Both are the same.
Plus 25.
Plus 25. Yeah. That's not answer. That's noise. Because I was not able to get you clearly, right? Yeah. Now multiplicative inverse. Wait. Okay, wait. Yeah, online children.
7 by 5.
Minus 1 by 5.
Sahasra, you were wrong. Disturb the number. What's the number? Don't disturb the sign. Disturb only the number.
Okay, ma'am.
What will you do? 5 by 7 should be
7 by
plus
5, ma'am.
sign.
Minus.
Write the same sign. You should change only the number.
Minus 17 by 9.
You're confused, Srijit. Okay. Multiplicative inverse, disturb the number, not the sign. Write the same sign. 5 by 7 is 7 by 5. Written as 7 by 5. 9 by 17. Change the number. 17 by 9. Don't disturb the sign. Same sign it will be. Yeah, Sahasra, next one.
1 by 3.
Yeah, don't change the sign. Plus, plus only. But what is this number? 3 means 3 by 1. 3 means it's 3 by 1. So change the number 1 by 3. Upside down, 1 by 3. Minus 25.
Minus 1 by 25.
Yeah, don't change the sign. Write the same sign. What is 25? 25 by 1. So change or write it upside down. 1 by 25. Okay.
Yes, ma'am.
Yeah. Okay. Yeah. All these images, see, whatever we have discussed so far in today's class, all these notes have been already shared with you on WhatsApp. All that we have discussed, notes have already been sent to you on WhatsApp. So you have not missed on anything. All right. Yeah. Now these images also have sent on WhatsApp. Correct. Yeah. No, I'll ask you. Okay. Now this one is for Srijit.
And
First
the
one,
first one,
all of you will get a chance. Srijit, fill in the blank. The first one.
minus 3 by 17, ma'am.
Minus 3 by 17. State the property, Srijit. Which property? No, listen to my question. Which property of rational numbers have you used to complete this equation? State the property of rational numbers you have used to complete this equation.
Associative property.
No. For associative property, we use 3 numbers, not 2 numbers. See.
Commutative property.
Huh?
Commutative property.
Commutative property.
Okay.
Now, see, I'll tell you how you can remember. Now, in apartments, you have an association, right?
Yes, ma'am.
Okay. Now, A, B, 2 members, 3 members. Which is big? 2 or 3?
3, ma'am.
Yeah, so associative means 3, like many.
Okay.
Commutative is only 2. You can remember like this also. A, B, C. Commutative, A, B.
Yes, ma'am.
Commutative property. Remember the letter A, B, C. Commutative property, only 2 numbers A and B.
Yes, ma'am.
Associative is like association. You need many people. But here many is 3 only. Many, 2, 3. Between 2 and 3, many is 3. So associative is like an association. You need many members. So ABC, associative property, 3 numbers. Commutative property, 2 numbers A and B. Okay.
Okay.
So the answer is minus 3 by 17. And the property we have used to complete this equation is the commutative property of addition of rational numbers. You must state the operation also. Commutative property of addition of rational numbers.
Okay.
Yeah, Sahasra, next one.
Minus 21 by 8.
Property.
Commutative of addition rational numbers.
Correct. Commutative property of addition of rational numbers. Okay. Yeah, next one, Harini. Now observe the 3 numbers here, Harini. Look at the 3 numbers here. So you look at them as A, B, and C. Okay. Look at the numbers. See here, this is A, this is B. Okay. What is this? This is B. No, so we should write A here. Look at the first one. This is A, this is B. So what do you have here? A plus B. A plus B is equal to B plus A, right? So you see, you have B here. So you have to write A here. The second one, this is A, this is B. What is A plus B equal to? B plus A. So you have B here. So we should write A here. Now in the next one, we have 3 numbers. This is A, this is B, this is C. Now what is this 3 by 7? It's B. What is minus 13 by 4? It is C. Then what should come here? Minus 8 by 13. A should come here. Minus 8 by 13. You just write the letters on it. A, B, C. And on the other side, we have B and C. We don't have A. So whatever is A, that should come in the blank. Yeah. So what's the property? Addition of rational numbers. Associative property of addition of rational numbers. Yeah, next one. This is A, this is B, this is C. What is this one? A, this one. So what should come here? Minus 9 by 11. Very good. Associative property of addition of rational numbers. Yeah. Anirudh? Okay. So this is A, this is B, this is C. So we have A here and we have C here. So this one is B, minus 3 by 11. Correct? Yeah, the last one. Oh, yeah, Navneet, I forgot. Yeah, Navneet. It will pass to you if he doesn't answer. Yes.
Ma'am, can I say the answer?
No, darling, wait. No, she's right. Yes. Srijit, what's the answer?
Ma'am, 0, ma'am.
0. A plus 0 is equal to 0 plus A is equal to A. You must write the rule and then understand. You must write the rule. Very good. You must write. Srijit, very good. You answered it right. You must write the rule. See, observe that first. You should not be hasty to answer. Observe. This is A. This is some rational number minus 16 by 7. Let's call it A. Plus dash is equal. Put A here also. See, it's like this, okay? It's like this. Okay, 1 minute. 1 minute. Don't confuse. Please wait. See, this is minus 16 by 7. So A. This is also minus 16 by 7. So A, you can't put B there. Same number, same letter you should use. Now, this is also minus 16 by 7. So this is also A. Now see here, the final answer is minus 16 by 7. What's the final answer? Minus 16 by 7. Then what should come here? 0. 0. Read this. A plus 0 is equal to 0 plus A is equal to A. A plus 0 is equal to 0 plus A is equal to A. The role of 0 or the additive identity. So here we use the additive identity property to complete the equation. It's not the commutative property. It's you should identify the property, like specifically, accurately. You should say the most appropriate identity. Now, see, when you say commutative, I can't say you're wrong, but that's not the appropriate identity to be mentioned here. I will not do. Okay, so please write the rule. Please write the rule, okay? See, I'm repeating this. This is A, same thing. So A, same thing, A. Look at the board, Navneet. See, that measures your attention. So you should observe the equation and see this finally is equal to A. You have is equal to A. You have to get the same rational number as the answer. And when can that happen? Only when you add 0 to the rational number. A plus 0 is equal to 0 plus A is equal to A. Correct? So we have used the additive identity property to complete this equation. So in the blank, you have to write, in the blanks, you'll have to write 0. Correct? Okay. So I have the answers here. Okay, I'll send it now itself on. Share the image on WhatsApp. Yeah, all if you write the answers for this, don't have to write the question. So this one also, as I told you earlier, I've shared the question on WhatsApp. Just write the answers for all. I just need to make a phone call. Write the answers, keep them ready. We'll discuss. Finished? Yeah, done. First one. So what will you do, children, to write the additive inverse? What's the rest of the sign? What is the other term for additive inverse?
Negative of a number.
Additive inverse or negative of a rational number. Negative of the rational number. Okay. So disturb the sign. Plus 1 by 3. Minus 1 by 3. Plus 23 by 9.
Minus 23 by 9.
Minus 18.
18.
18
Plus
or plus
18.
18. 17 by 8.
8. Minus 15 by 8.
No, it's minus already here. So plus 15 by 4.
Okay.
Here minus and minus will get cancelled. So it is 16 by 5. So the negative is minus 16 by 5. In this number, you can cancel the signs. So the number is only 16 by 5. Minus and minus gets cancelled. So the number is 16 by 5. What makes you smile so much? Minus 16 by minus 5. You can cancel the minus in the numerator and denominator. So the number is 16 by 5. So plus 16 by 5 is a number. Its negative is minus 16 by 5. Here, 3 by 11. 0, 0. Minus and minus cancel, so minus 8 by 7. Which one? No, answers are here. Huh. No. No, minus 16 by minus 5, you can cancel the minus signs. No, so what's the number? The number is 16 by 5. This is the question, okay? Minus 16 by minus 5 is a question. The question can be simplified. We are not writing the answer. This is the question, and this can be simplified. And so the question is actually 16 by 5. We have not answered at all. We are still in the question. See, the question is this, right? We are cancelling the minus signs. We are still in the question. Now this is the question, 16 by 5. Now change the sign, write the opposite sign, minus 16 by 5. When you're cancelling the minus signs, you're still in the question. You're simplifying the question. So 16 by 5 is the question. Negative is minus 16 by 5. So see, when you have the negative sign in the denominator, 15 by minus 4 is nothing but minus 15 by 4. When the negative sign is in the denominator, you take it up to the numerator. 15 by minus 4 is nothing but minus 15 by 4. And its negative is plus 15 by 4. This is nothing but this. And its negative is this. See, what I've written here is a question itself. Minus 16 by minus 5, minus and minus cancel. So it is 16 by 5. And this is its negative. 19 by minus 6 is nothing but minus 19 by 6. This is the question. And the answer is plus 19 by 6. Minus and minus cancels. So it's 8 by 7. This is the question, 8 by 7. So minus 8 by 7 is the negative. All right. And you should always write it as a statement. You should not write 1 by 3 is equal to minus 1 by 3. You must write it as a statement. The additive inverse of 1 by 3 is minus 1 by 3. You should not write 23 by 9 is equal to minus 23 by 9. Yeah, they're not equal. They're not equal. So you should not. Now it's okay. Now we've been answering it roughly. So if you've written it like that, that's fine. But yeah, otherwise, when you are answering this question in your classwork notebook or any, other than just discussing roughly like this, you have to write it as a statement. The additive inverse of 1 by 3 is minus 1 by 3. You must write it as a statement like this. All right. Okay. Any doubts here, children? So whenever simplification, so what are the different, types of question we saw here? When the minus sign is in the denominator, you should put it in the numerator. So this is the question. This is also the question only. You're just taking the minus sign to the numerator. We are still in the question here. And the negative of this is plus 15 by 4. Here, minus and minus cancels. So the question is, the simplified version of the question is 16 by 5. And its negative is minus 16 by 5. The minus sign is in the denominator. So take it up to the numerator. This is the question. And the answer is plus 19 by 6. Minus cancels. So this is the question. This is the simplified version of the question. The question is 8 by 7. And its negative is minus 8 by 7. Wherever, yes, whenever the question can be simplified, you should simplify the question and then answer it. Always, not only in this question, not only when the heading is this. Every time you can simplify, you should simplify and then answer. Yeah. Name the properties of addition in each of the following cases. Just tell me like that in chorus, yes. Completed. Commutative. Commutative property of addition of rational numbers. Next one. Okay. Yeah, one second. Okay. So the first one is A plus B is equal to B plus A. So it's the commutative property of addition of rational numbers. You can say commutative property for addition of rational numbers, not over. This one is A, B, C. Okay, so this is the associative property of addition of rational numbers. This one, yeah, right, additive identity property. Additive identity property. We'll not write role of 0. I just mentioned that because in some books, you can see that the role of 0, the role of 1. Yeah, you said both, but write only, you say both now, but when you write in the exam, write additive identity property. The role of 0 is not very specific. It was a general heading kind of thing. You should understand. See, that cannot be explained. Yeah, you want me to explain why you should not write the role of 0 and why you should write additive identity. Sometimes simple things become too difficult to explain. So, no, this one. What is this? Online children, what is this? What's the property here?
Ma'am, commutative, ma'am.
Srijit, no.
Associative.
Which one? Okay, 1 minute, 1 minute. Okay, Srijit, the property for the first one?
Commutative, ma'am.
Commutative property of?
Additive rational numbers.
Addition. Commutative property of addition of rational numbers because the sign is plus. A plus B is equal to B plus A. Okay. The next one, what's the property for the second one?
Associative, ma'am.
Associative property?
Of addition of rational numbers.
Of rational numbers, yes. Now, Sahasra, the third one?
Role of 0.
Correct. So, it's a role of 0, also called the additive identity property. Additive identity property.
Additive identity.
Property. Additive identity property, or see here, additive identity of rational numbers. I'll share this image with you. Additive identity property or additive identity of rational numbers. Okay, the fourth one. Because why is 1 minute?
Associative.
The third one is A plus 0 is equal to A is equal to 0 plus A. Yeah, the fourth one.
Associative property, addition of rational numbers.
Yeah, it's okay. Yeah, now the last one.
Role of 0. Some commutative property.
No. One second. No. Yes. Additive inverse. No. Srijit?
Ma'am?
Yeah, what do you say for the last one? Property?
Ma'am, I said commutative property.
No. You must mention the most appropriate property.
Additive inverse.
Correct. Additive inverse. Additive inverse. Additive inverse property. What do you mean by additive inverse property? If the sum of two rational numbers is 0, when the sum of two rational numbers is 0, then the first rational number is said to be the negative or the additive inverse of the second, and the second rational number is said to be the additive inverse or the negative of the first. Additive, inverse, and negative both are the same, right? Additive, inverse, and negative both are the same. So you can see that the sum of this rational number and this rational number is 0. This is A, this is B. These two are different rational numbers. A and B are two. See, A is 5 by 3, B is minus 5 by 3. This is B, this is A. So what do you see here? We see A plus B is equal to B plus A is equal to 0. The sum of these two rational numbers is equal to the sum of these two rational numbers is equal to 0. So here the additive inverse property is demonstrated. Most appropriate. Exactly what you must say. You must not say, you must say exactly what. It exactly represents what? It exactly represents the additive inverse property. Yeah, exactly what we saw earlier. When, how do you understand the additive inverse property? You have a rational number 5 by 3. What should you add to that so that the sum is 0? So minus 5 by 3 is the negative of 5 by 3, or minus 5 by 3 is the additive inverse of 5 by 3. So you have a rational number minus 5 by 3. What should you add to this so that the answer is 0? 5 by 3. This property is what is demonstrated here. So it's the additive inverse property. See, you should split this and see. We'll write both. See, what you see there is 5 by 3 plus what is 0 minus 5 by 3 plus something is 0. See, these are the two things you see here. This one I've written it separately. Can you see this? 5 by 3 plus 5 by 3 plus what will be 0? And minus 5 by 3 plus. Now, when you write these two together, 5 by 3 plus minus 5 by 3 is equal to minus 5 by 3 plus 5 by 3 is equal to 0. Instead of writing is equal to 0 two times, they've combined this. This one is equal to this one is equal to 0. The answer for this one is 0. The answer for this is also 0. So what you see here is, this one, this answer is equal to this answer is equal to 0. What is the answer for this one? 0. You can see it here, is equal to 0. What's the answer for this one? 0. So instead of writing 0 two times, this answer is equal to this answer is equal to 0. This is a rational number. This is its inverse. Or if you take this as the rational number, this is its inverse. Their sum is 0. All right. So the additive inverse property. And that will, I don't think we have time today. We'll see this later. Yeah, we're doing the others. Yeah. Which rational number is its own additive inverse? Which rational number is its own additive inverse? That means which rational number added to itself will give 0 as the answer. See, additive inverse means the sum should be 0. Additive inverse means the sum should be 0. A rational number plus another rational number should be 0. Now, 1 minute. All of us should understand 1 minute. Which rational number is its own additive inverse? That means they are asking you which rational number plus that rational number itself will give you the answer as 0. You take a rational number, you add it to itself, and the answer should be 0. Then it is 0 only. 0 plus 0 only is 0. Yeah, I got it. Your answer is right. Additive inverse means rational number plus rational number is equal to 0. So 0 only, no 0. 0 plus 0 is only 0. So 0 is the rational number, which is its own additive inverse. Is the difference of two rational numbers a rational number? The difference of two rational numbers. When you take two rational numbers, you find their difference. Will the answer be a rational number? Yes. The difference of two rational numbers is always rational. The difference of, that's what is the closure property. The closure property holds good for addition, subtraction, and multiplication, not for division always. The difference of two rational numbers is a rational number. Correct. When you take a rational number and another rational number and find their difference, the answer will be rational. That is the closure property. Yeah, rational number minus rational number is equal to rational number. Is addition commutative on rational numbers? 1 second. Children? Navneet? No, it's nice, but it's disturbing also. Yeah.
The second question answer is the same as closure property.
Closure property. True. Is the
Same as closure property.
it is the yeah, that's what the closure property is, what is asked here. Is the difference of two rational numbers a rational number? Yes. R minus R is always R. Yes. Is addition commutative on rational numbers? Yes or no? Yes. Okay. Is addition associative?
Yes.
Is subtraction commutative?
No.
Is subtraction associative?
No.
What is the negative of a negative rational number? See, what is the negative of a negative rational number? Take a negative rational number, like say minus 3/4. Okay. See, this is a negative rational number. Minus 3/4 is a negative rational number. What is the negative of this? 3/4. It's positive. All of us should understand. 1 minute. Yeah. What is the negative of a negative rational number? So let us take a negative rational number. Minus 3/4. Now, what is the negative of minus 3/4? 3/4, it's positive. You've written the same question, huh? Okay, the last one. What is the negative of the negative of a rational? What is the negative? Okay, they are different. You should answer. You should get the difference between the two. If you go through all the answers, this is how you write it. When they ask you is, when they ask you is, you should not write true or false. You must write yes, no. Right? Yes, no. They're asking you, is the difference? Is it? Yes, no. Don't write true, false. Yeah. You just need to send a message. 1 minute. Just go through the answers.
Ma'am, you are in mute, ma'am.
Sorry. You don't see the answer. You see the question here. See the question. I'll give you 2 more minutes time. 3/4. And its negative is again the number itself. You can just think about it. See, I presented the answer. We try to understand. And you tell me in the next class or by the end of the class today. You can see the answer also there. This image also was shared, no, with you on WhatsApp. These questions. Okay, so the 7th and the 8th one are kind of clashing, but they are different. Yeah, the 7th and 8th, they look almost the same, but they are different. You need to get, you can also see the answers there. Read the question, get the difference. One word, 1 or 2 words make a lot of difference in the meaning. Okay, so try to understand that by yourself. Yeah. So we'll take this as A, B. So what is here? B. So what should come here? A. And what is it? Minus 23 by 17. What properties are demonstrated here?
Commutative.
Yeah. Commutative property of multiplication of rational numbers. Yeah. Next one. Second one. Again, commutative property. Associative property. Associative property of multiplication of rational numbers. Because three numbers. Association. Then associative property of multiplication of rational numbers. We'll come to that. We finished commutative for addition and multiplication. Now this is associative.
And about the answer.
Very good. Yeah. What's your doubt? No, yeah, no. What is that you're talking?
It's like 15 pages a day. Like not what kind of
Yeah. Now what do you do to find the multiplicative inverse? What should it disturb? Disturb the number, not the sign. 1 minute. Change the number, not the sign. Change the number. That is, yeah, disturb the number. Don't disturb the sign. Disturb the number, not the sign. Disturb the number. Write the number upside down. Don't disturb the sign. Okay. So 13 by 25. 25 by 13. Don't disturb the sign, right? Minus as it is. 12 by 17. 1 by 18. You said minus. No, no, no. For 18, what did you say? 1 by 18. Fourth one. Online children. What's the answer for the fourth one?
1 by 16. 1 by 16.
No, fourth one.
1 by 18.
1 by 18. Because 18 is 18 by 1. So disturb the number 1 by 18. Don't change the sign. Plus 1 by 18. What about the fifth one?
Minus 1 by 16.
Yeah. Don't disturb the sign. Write the sign as it is. Invert the number 1 by 16. So here in the sixth one, you can simplify the question. The question is 3 by 5. In question number 6, you can simplify the question. Minus cancels. So it is 3 by 5. And its reciprocal is 5 by 3.
5 by.
So minus 1. Don't disturb the sign. It's minus. What's the
1 by
reciprocal? Write the number upside down. 1 only.
Minus 1 by 1.
Which is minus 1? Which is minus 1? The next one, 0 by 2. 2 by 0, which means it's not defined. It's not defined. What is 0 by 2? 0 by 2 means 0. The reciprocal of 0 is not defined. What is 0 by 2? 0. What is 0 by 2? 0 by 2 is nothing but 0. And what's the reciprocal of 0? It's not defined. 0 by 2 means 0. The question is 0. The reciprocal of 0 is not defined. Because what should you do? You should invert the number. 0 by 2 will become 2 by 0. Division by 0 is not defined. 2 by minus 5?
5 by.
Yeah, have a look at the answers. Oh, here I've gone wrong. This is a mistake. Typing error, typing error. You should excuse me for that. This answer is no 5 by 3. Srijat, disable your mic. Yeah, the others are correct. Yeah. Anirudh, first one. Commutative property of multiplication of rational numbers. Second one. Yeah, see, you lost your focus. Yes, what's the second one? Third one? Anybody? Third one?
Associative property.
Third one, no? Sahasra?
Yes, ma'am.
Observe the third one, Sahasra. See here. Let me call this A into, this is B plus C. Can you see something like that?
Yes, ma'am.
Okay. So what is minus 3 by 4 here on this side? A, B or C?
A.
Okay. The operation is multiplication. What is minus 5 by 6?
B.
B. Here plus. What is minus 3 by 4?
A.
Into, what is 7 by 8?
C.
See, now read this. A into B plus C is equal to A into B plus A into C.
Yes,
So
ma'am.
now tell me the property.
Distributive.
Distributive property of multiplication over addition. Distributive property of multiplication. This is distributive, not associative. Distributive. Yeah, addition and subtraction. A into B plus C is equal to A into B plus A into C. If you use ABC and check the property, this is how it reads. A into B plus C is equal to A into B plus A into C. This is the distributive property of multiplication over addition because the sign here is plus. If this is minus, then it will be minus here, then subtraction. Next one, Srijit.
Which number?
Okay, Srijit, what's the answer we discussed for the third one?
Ma'am, distributive property, ma'am.
Completed. Distributive property of
Addition of rational numbers. Multiplicative of rational numbers.
distributive property of multiplication over addition. Repeat.
Distributive property over
Of multiplication
multiplication over addition.
over addition. So tell me the property in general. How will you state the property in general using the rational numbers A, B, and C?
Minus 3 by 4 as A.
No. Leave that. Leave that question. In general, how will you demonstrate the distributive property using the rational numbers A, B, and C?
Ma'am, I can't understand.
Okay, I'll start you complete. A into B plus C is equal to complete.
Okay, ma'am. A into B plus A into C.
So this is how you demonstrate the a distributive property of multiplication over addition using the rational numbers A, B, and C.
Okay, ma'am.
Okay. The fourth one, answer with the fourth one, children.
Multiplicative.
Yeah, multiplicative identity property. Identity means same answer you must get. No, that's how we should remember. Inverse for multiplication, is it? Multiplicative inverse meaning one number into another number should be 1.
Reciprocal of the same number so that it can cancel.
Identity and inverse. See, the difference is Anirudh. Identity means take a rational number, add something to it. Should get the same answer. Identical answer. Okay, wait. Identity means take a rational number. You add something to that rational number. You must get the same rational number as the answer. See here, 1 minute. No, you must get the difference. Rational number plus something should give you the same rational number as the answer. Then what should be that something here? 0. So 0 is called the additive identity because you're getting the same answer. Now, no, the other one is multiplicative identity. Multiplicative identity means rational number into what will give the same rational number as the answer. 1. So multiplicative identity is 1. Rational number plus what will be the same rational number? Rational number into what will be the same rational number? Rational number plus 0 is equal to the same rational number. Rational number into 1 is the same rational number. So 0 is called the additive identity. Identical answer, same answer. 0 is called the additive because addition here. 0 is called the additive identity of rational numbers. 1 is called the multiplicative identity of rational numbers. This is identity. Now coming to additive inverse and multiplicative inverse. Inverse is now coming to additive inverse and multiplicative inverse. Additive inverse means rational number 1 plus rational number 2 is equal to 0. Multiplicative inverse means rational number 1 into rational number 2 is equal to 1. Inverse means additive inverse. Rational number 1 plus rational number 2 is equal to 0. Multiplicative inverse means rational number 1 into rational number 2 is equal to 1. So if you take the rational number 3 by 4 plus what is 0? Minus 3 by 4. So minus 3 by 4 is the additive inverse of 3 by 4. And 3 by 4 is the additive inverse of minus 3 by 4. Now if you take minus 7 by 8 into what will give you 1? Okay, you can put the minus anywhere. Yeah, you said the same thing. Navneet is saying 8 by minus 7, right? Relax. It's the same. Minus 8 by minus 7, minus 8 by 7, minus 8 by C. All are the same. Minus 8 by 7, 8 by minus 7, or minus 8 by 7. Everything has the same value. Oh, minus into minus is plus, no? Oh, you want to cancel the minus. So 1 minus should be in the numerator, 1 should be in the denominator, is it?
Yeah.
Minus into minus is plus. So you can put this minus here also. So 7 and 7 cancels, 8 and 8 cancels. Now minus 1 into minus 1. See, when you cancel, it's 1 everywhere. So minus 1 into minus 1 is plus. Yeah, so in the fifth one, multiplicative inverse property. In the fifth one, it is 1 minute, children. The fourth one is multiplicative identity property. Identity, because it's saying getting the same answer. Not additive, multiplicative. Nothing is additive here. Everything is multiplication. No. 1 minute. We have to wind up the class. We just have 5 more minutes. Online children, the property for the fourth one is multiplicative identity property. Multiplicative because you can see the multiplication sign. Identity because you're getting the same answer. This rational number into 1 or 1 into that rational number is the rational number itself. The answer for this one, what's the answer for this? Is minus 16 by 9. What's the answer for this one? That also is minus 16 by 9. That's what is written here. This answer is the same as this answer is equal to this. So here, what is reflected there? The multiplicative identity property. But in the next one, multiplicative inverse property. Inverse, because rational number 1 into rational number 2 is the same as rational number 2 into rational number 1 is equal to 1. You will get confused. You have to practice to remove. You will. When you take it individually, you are clear, no? That happens. Sometimes you will be clear, but then you feel you're confused. You are able to answer the question, so you got it clearly. But when you just think of all the 4, no, you feel like no, it's not clear. That happens because you're able to answer. No, one by one, when we do it, you're able to answer. So the fifth one is rational number 1 into rational number 2. They are different rational numbers. Rational number 1 into rational number 2 is equal to rational number 2 into rational number 1 is equal to 1. That means the product of these two is 1. The product of these two is also 1. So here what is represented? Multiplicative inverse property. Multiplicative inverse property. And the last one, how was it additive? How was it additive? There is 0 into 0. You can just say that the product of a rational number and 0 is 0. The product of a rational number and 0 is 0. You can just write what I said because yeah. We'll quickly discuss this and wind up the session for today. The product. So this is what I had shared on WhatsApp. Okay. Yeah. The product of a rational number and its reciprocal is? The product of a rational number and its reciprocal is? 0 has no reciprocal. The numbers dash and dash are their own reciprocals. And
0.
0 does not have a reciprocal.
Oh. Ma'am, what?
The numbers 1 and -1 are their own reciprocals. What's the reciprocal of 1? 1. What's the reciprocal of -1? -1.
Plus 1.
The numbers 1 and -1 are their own reciprocals. See here. What's the reciprocal of 1? How do you find the reciprocal? You should disturb the number, not the sign. So how do you invert 1? 1 only, no? And -1, don't disturb the sign, only the number you should change. What's the reciprocal? How do you invert 1? Same thing. So the numbers 1 and -1 are their own reciprocals, meaning the reciprocal of 1 is 1. The reciprocal of -1 is -1. Because see here, 1 into 1 is 1. -1 into -1 is 1. How do you understand reciprocals? Rational number into R1 into R2 should be 1. Reciprocal 1 in, sorry, rational number 1 into rational number 2 should be 1. That means they are reciprocals. Rational number 1 into rational number 2 should be 1. So what is 1 into 1? 1. And what is -1 into -1? 1. So that means 1 and 1. 1 is the reciprocal of 1 and -1 is itself. Right? 0 is not the reciprocal. 0 is not the reciprocal of any number. The reciprocal of A is not 0, okay? A is not 0, something other than 0. So the reciprocal of A is 1 by A. The reciprocal of 1 by A is not 0. So the reciprocal of 1 by A is A. The reciprocal of a positive rational number. Positive. Because what do you do for reciprocal? We don't change the sign. We don't disturb the sign. We only disturb the number. So if the rational number is positive, reciprocal is positive. Because for reciprocal, we disturb only the number. We don't disturb the sign. For reciprocal, we don't disturb the sign. Only the number we'll disturb. So if the rational number is positive, reciprocal is positive. Rational number is negative, reciprocal is negative. Very good. All right, children, listen to this. All answers to the assignment which I shared on WhatsApp has been posted now on WhatsApp. Okay, so we have completed it end to end. Got it, online children?
Yes, ma'am.
Yeah. All right, children. So that's it for today's session. Thank you so much. Online children can leave the call. Good night.
Thank you, ma'am.